All right, we're finishing up this chapter 3 on linear functions, and we're getting ready to move over to chapter 4, equations of linear functions. But before we do, we're going to take a quick look here at proportional and non-proportional relationships. And we're going to start here with proportional relationships. Now, characteristics of proportional relationships. If we were to graph these, we would find that the relationship between the domain and the range are linear. In other words, if we graph the data, we're going to end up with a line from that data. We're also going to determine that we've got an equation that is going to be like a direct variation equation, y equals kx, that would satisfy the data that we have. And thirdly, if it's a proportional relationship and we were to look at the graph, we would find that the graph will pass through the origin where x is equal to 0 and y is equal to 0. Now, on page 198, we got example 1, which is a proportional relationship. And we're given some data here along with a little descriptive that a professional soccer team is donating money to a local charity for each goal that they score. And we've got a table here that gives us number of goals and the amount of money donated. And I can look at this as this first row is giving me x values and this second row is giving me y values. I wouldn't have to use those variables. I could use G for goals, let's say, or D for donations. I just like x and y when I can use them, so just to kind of be consistent. And then we're asked to write an equation to describe this relationship. Well, what I want to do first is I want to look at is there a common difference between my x values and my y values, and what's the relationship between those? And here I see that my common difference between 1 and 2 is in fact 1, and 2 and 3 is 1, and 3 and 4 is 1, and 4 and 5 is 1. And so I can pretty well satisfy that I've got a common difference of 1 on my x values. And what about my y values? Well, the difference between 150 and 75 is 75. And the difference between 225 and 150, again, is 75. And the difference between 225 and 300 is 75. And the difference between 375 and 300 is 75. And so I've got a relationship, say 75 to 1. Every time x goes up by 1, y goes up by 75. And therefore I can write an equation in the form of y equals kx as this y equals 75x. Now I want to test this to see if this is actually true, and I'm going to take a couple of test points. I think I'll take 2 and 4 just to see how that goes. So I would say y equals 75. What does y equal when x is 2 in this relationship? Well, 2 times 75 is 150. So when x is 2, y is 150. And I see that that is true right there from my table. Let's take one more test point. So that y equals, what does y equal when x is 4? Well, I plug in, so I got 75, and I'm going to plug in 4 for x. Well, I know that 2 times 175 is 150, so 4 must be twice as much as that, so y would equal 300. And I go back to my table, and I see, yes, in fact, when x is 4, y is 300. So I'm pretty well satisfied that my equation, y equals 75x, is going to give me what the data represents. Now, we talked about, though, that in a proportional relationship, it is going to pass through the origin. In other words, when x is 0, y is 0. So I'm going to do a test on that just to see if that's true. So I would say what does y equal when x is equal to 0? Well, 75 times 0 is just going to be 0, and so y is going to equal 0. So I'm pretty well convinced that I am dealing with a proportional relationship. I'm meeting all the tests. And that this equation, y equals 75x, is true to represent the data that I have been given. Now, lastly, it says use this equation to predict how much money will be donated for 12 goals. So I'll go y equals 75, and I'm going to substitute 12 in here for x, our number of goals. And when I get my calculator out, which is what I would do, and multiply 75 times 12, I'm going to see that it equals $900. So that's using the equation to predict in this proportional relationship. Now we're going to move over and look at a non-proportional relationship and see what we need to do to try to determine an equation or a function for that. It's got a little bit of a difference to it. Start off the same way, but we got to have an added step. All right, so like I indicated, we're going to look at a non-proportional relationship. And here again, we're being asked to write an equation for the relation shown in the table. And so in this table, I've got some x and y values. And I'm going to start off the same way that we did for the proportional relationship. And I'm going to look, okay, well, what's my common difference? Well, the difference between 1 and 2 is 1, and 2 and 3 is 1, and 3 and 4 is 1. So my common difference on my x values are 1. And let's see, what about my y values? Well, the difference between 2 and 3 is -1, and between 2 and 1 is -1, and 1 is 0 is -1. So I could think, okay, well, I've got a ratio here of -1 to 1, and if I were to put that in a direct relationship or proportional, I would say that -x equals y. Now we're going to do some test points in here, and we're going to say, okay, well, let's use -x, and does this equal our y value? So I'm going to put in here -x. So when x is 1, -x is -1. And when x is 2, -x is -2. And when x is 3, well, that's -x is going to be -3. And when x is 4, -x is going to be -4. And I see here that this is not representing my y value. So something else is going on. And so when I discover that, what I want to do is I want to see, okay, well, is there a common difference between this -x and the y? Well, the difference between -1 and 3 is 4. Yep, 4. And the difference between -2 and 2 is also 4. And the difference between -3 and 1 is 4. And the difference between -4 and 0 is 4. So I then would write this equation then as such. I could say first here that y equals -x plus 4. And if I were to write that in function notation, I could say that f of x equals -x plus 4. All right, well, there we go. There is our function notation for the data that we've seen. We compared our x values, got a common difference. We compared our y values and got a common difference. And then we tested that relationship to see if that gave us true statements, which it did not. And so then we evaluated our difference between our relationship, -x, and determined that we did in fact have another common difference of 4 in each case. And so therefore we can take that information and develop a non-proportional relationship. Now let's, just for fun, since it's non-proportional, it should not pass through the origin. What if we go in here and say, okay, well, what about when x is 0? So we got f of 0 equals negative 0 plus 4. What's y going to equal when x is 0? Well, negative 0 and 0 is just 0. And so f of 0, or y, when x is 0, y is going to be equal to 4. It's not going to pass through the origin, which is another indication that it's a non-proportional relationship.